Today we're going to talk about graphing exponentials and logarithmics. So our first example we look at has 2 times 3 raised to the x plus 1 and then off to the side plus 3. To graph this, you're either going to have to use a graphing calculator or Desmos, and I will be using Desmos for this online video. So I will be going to Desmos and I will be typing in our first one. So we have 2 parentheses, 3, close my parentheses, raised to. Now you're going to notice the power has more than just one item. So on Desmos, to keep both of those items up as powers, you have to use a parentheses around them. If you are using a graphing calculator, you do not, because they know to keep it all up there. So now if I kind of zoom around and look at my picture, you're going to notice that you have a curve. And on the left side, it kind of looks like it's going down a straight line, and then it hits a curve and goes up. So now we do have some review topics to talk about before we actually sketch our picture. And the first thing we would like to talk about is the range or domain. And you need to remember that domain is your x numbers. Okay, so now we're going to go back to our picture and we're going to look at our x numbers. And when you look at the left side of the picture, you're going to notice that it's going on forever and ever. So that's going to be toward an infinity. And remember, we always put parentheses around infinity. So we have negative because it's on the left. And then when you're on the right side, you're going to notice that as it's curved, it's going up. But as it's also going up, it's going out farther and farther to the right. So then on that, you're going to also say positive infinity. And remember, parentheses goes around infinity. Now, for the range, you have to remember the range is y numbers. So now when I go back to my picture, and I start at the bottom and I work my way up, it looks like I'm going to touch first right here, and this would be at 1, 2, 3. So then we're going to have 3. Now here's the tricky part, is most people want to look at the picture and they want to say, oh yeah, it touches at exactly 3, so I want to put a bracket around it. But what happens is here you notice that on the y values, your calculator or Desmos is going out 3 places. It's going out 3 places, and then all of a sudden it's saying, oh, this is going to switch from 3 places to going out 4 places. But we don't really switch out 4 places or anything above, so we're just going to round it to a number. But what you need to realize is that it's still really like 3.00008, 3.00005. But the Desmos and the calculator can't handle that, so they round it. So it's not actually ever going to touch this number right here at 3, even though the picture looks a little deceiving. So it is a parentheses. And then it does go up forever and ever, so that would be positive infinity. And then your asymptote, well, asymptotes are lines that the graph gets really close to. They can be horizontal or vertical. And in our case, you would want a horizontal line right here. And you would want to say that it is y equals 3, because remember we just talked about how it wasn't ever going to touch 3. It was going to get awful close to it, but not actually touch it. So right here you would say y equals 3. But let's look back at the original problem, because if I look back up here at the original problem, does everybody notice here at the end it does say plus 3? For exponentials, that number at the end will be the beginning number for the range, and it will also be the number that you put for the asymptote. Now, one thing I do want to go back and mention for the range, okay? For the range here, the book says, here's another way we can write range. Instead of saying 3 to positive infinity, you're basically telling everyone that you're using all y numbers that are bigger than 3. So you could write it as y is greater than 3. So you can either write it the old way with the infinity, or if you want to write the new way with an inequality, you can. So now I'm just going to go put my asymptote in, which is at +3. Remember, asymptotes are dashed lines because they're not actually part of the graph. And then we're just making rough sketches. So it doesn't have to be anything super, super accurate, but we noticed on our picture, we followed this line right here. And then we started to curve and go out. And you're done. Okay, now on the second one, for this notes, I don't know if your notes has been fixed or not, but for mine, I put a negative in front of this 1/2. So now I'm going to go back to Desmos, and I am going to get rid of this one and type in our new one. So for this, I'm going to use negative. So negative, and then I'm going to do 0.5 instead of 1/2. And then E raised to, and then remember parentheses to keep it up there. So X plus 3, close my parentheses, and then arrow down -2. Okay, so then once I have that, I'll adjust my screen here. And you'll notice when there's a negative in front, instead of left and going up, you're going to notice now it's on the left and it goes down. Okay. So for domain, we're still going forever and ever on the left. And as it's curving down, you're going to notice it's actually also going out to the right. So guess what? The domain for all exponentials is always going to be -infinity to +infinity. An exponential is where you have your x as a power, and it can have the letter e or it cannot have the letter e, but it just does not have log or ln in it. Range. So once again, if you want, you can look at the last number at the end, which is our -2. Or if you want to look back at the picture, you could say, oh, okay, at the bottom, it's going down forever and ever. So that's a -infinity. And then at the top, it would hit right here at -2. Close. So you could say -2. Oh, sorry. Let me erase that so I'll get it the correct way here. -infinity to -2. Because we got to remember, go smallest to largest. So -infinity to -2. Or you can say it's all y numbers less than -2. And then your asymptote is still going to be a horizontal line. So it's going to be y equals, and then it's at -2. So I'm going to put my dashed line through here at -2. And then I'm just going to make a rough sketch of what my picture looks like. So then I'm going to say we're starting ever so close here. And then we're going to start and curve out. And there is my picture. Now, when I get to the third and last one here, you're going to notice, ooh, this one is not exponential anymore. This one has a log in it. So if it has a log or an ln, then that means it's going to be the opposite or the inverse of exponentials. Okay, so if it's the inverse of exponential, then instead of your domain being all real numbers, then it would have to be the opposite, which is range. So that means the range would be all numbers. And up here for exponentials, instead of your range being where you have a number infinity, that's going to be your domain. So your domain will now have a number and some kind of infinity, whether it's positive or negative. And if you want to do the new way, instead of saying y, it would be x is greater or less than a number. And then your asymptotes, instead of your asymptotes being a horizontal line, your asymptotes now have to be opposite, which is a vertical line. And vertical lines are x equals instead of y equals. Okay. Now, we also talked about the number that we were going to use here with the isotopes and stuff like that would be the number at the end. Well, if you're doing logs, it's got to be opposite. So it's not the number at the end. You're going to be looking at the parentheses part. And in the parentheses, I have x minus 2. So just set that equal to 0. Pretend like you solve it. So you have x equals positive 2. Now, we can also verify this on Desmos, but just trying to, show things backwards. So now I'm going to go to Desmos, and I'm going to get rid of this, and I'm going to type in the new one. Okay, so now if I'm typing this in, whoops, did not want to do that. Okay, for Desmos, I have to use my keyboard down here, keypad, boom. And then over here under functions. And then under functions, I want to scroll down until I get to the calculus part. So right up here, it says calculus. And then right here under calculus, it says log base A. And then that allows me to type in the base number with the log. Okay. And then I'll do x minus 2, close my parentheses, plus 4. Okay, and then when you look at this picture, you're going to notice there's no longer a asymptote that's a horizontal line. Your asymptote is now a vertical line, which is what we talked about, and then it's getting ever so close to 2. Okay. So for this one, on the left side for the domain, you're going to say, 2, and then the right side, it goes forever and ever. And just like we talked about, it's not ever going to be exactly 2. Okay, it's just going to get ever so close to it. So here I would say 2 to positive infinity. Your range will be everything. So negative infinity to positive infinity. And then our asymptote is x equals 2. So then I'll come over here and put my dashed line in at 2. And then you're going to notice it starts at the bottom, follows 2, and then starts to curve up. Okay, here's a nice easy point to, look at 5, 5. So then I'm going to go back here. So I'm going to say that we start down here. We're going to be ever so close to 2, and then we're going to start to curve and go out. And we're done. That's it.